Up until now, we have been talking about propositional logic only, which is all about a statement or proposition that can be true or false. There is no need of complex math symbols to demonstrate propositional logic. Unlike propositional logic, in which statements describe a specific fact, predicate logic statements use symbols, mathematical symbols and functions, and are true for a range of values. Predicate logic has two forms: first-order logic, which allows us to easily quantify relationship by simply representing objects and operations with simple math symbols. Second form is higher-order logic, which has a strong semantics and more expressive. You need to have understanding of the complex math functions and theorems to write higher-order logic statements. Predicate in first-order and higher-order logic simply shows a relationship among the objects, constants, or variables. In first-order logic, a statement is not a straight sentence made of words. A sentence in first-order logic is made of terms and quantifiers. Terms are composed of constants, symbols, variables, and function symbols. Propositional logic statement "it rained on Tuesday" can be written with the help of predicate weather, and we can replace day of the week with variable x. So we can write it as weather bracket x comma rained bracket close. These are some of the connectors, quantifiers, constants, variables, and predicates and functions you can use in first order and higher order logic. Higher order logic uses additional quantifiers and a stronger semantics. Using mathematical functions, we can quantify not over just objects, but we can quantify over relations as well. Consider the statement two functions are equal if and only if they produce the same value for all arguments. You cannot write this statement using propositional logic or rules of the first order logic. This statement is a theorem and it involves functions. Using the symbol f and g for the functions and quantifier for all, we can read it as for all f and for all g. F is equal to g if and only if. For all x, f of x is equal to g of x.